So now our next question is question number 14. Differentiate this expression with respect to x. Solution, let f of x is equal to 1 plus x square root minus square root 1 minus x square root 1 plus x plus square root 1 minus x. Again, if we see this question, then this is of the form fx over gx, so we can apply our quotient theorem here, but that will be more complicated to start differentiation. So first we simplify this question by applying rationalization. So multiplying this expression by square root 1 plus x minus square root 1 minus x and square root 1 plus x minus square root 1 minus x. So if let this one is a minus b into a minus b, that is of the form a minus b whole square, so that will become square root 1 plus x minus square root 1 minus x whole square, and in the denominator this is of the form a plus b and a minus b, so there will be a formula a square minus b square, so square root 1 plus x whole square minus square root 1 minus x whole square. We can use here a minus b whole square, that will be a square, so square root 1 plus x whole square will become 1 plus x, then plus square of square root 1 minus x, that will become 1 minus x minus 2ab. This one is a and this one is b, so that will become square root 1 plus x into square root 1 minus x. In denominator, this square and square root will be cancelled out, so we have square root 1 plus x minus 1 minus x. This plus x and minus x will be cancelled out. 1 plus 1 will become 2 minus 2, and this will be 1 plus x and 1 minus x as it is, and in denominator 1 plus x minus 1 plus x. This plus minus 1 will be cancelled out, so 2 can be taken as a common factor, that will become 1 minus square root 1 minus x whole square. We can write it as 2 minus 2 square root 1 plus x 1 minus x whole divided by 2x. So we can take 2 as a common factor, so we have 1 minus square root this 1 plus x and this 1 minus x will become 1 minus x square. 2 will be cancelled out. The expression which left is 1 minus square root 1 minus x square divided by x. So this one is f of x, which is simplified version of the given question. Now we apply differentiation on both sides. Left side will become f prime of x, and on right hand side we can use our quotient theorem here by applying derivative like d by dx of 1 minus square root 1 minus x square whole divided by x. So this is of the form fx divided by gx. So we use quotient theorem here, and that will be square of the denominator x whole square, x will be as it is, derivative will apply on numerator, which is 1 minus square root 1 minus x square, minus, then derivative will apply on x, and 1 minus square root 1 minus x square will be as it is. So when we apply derivative of this on this part, derivative of 1 will become 0, this minus will be as it is. We use our power theorem on this expression, so that will become 1 by 2, 1 minus x square raised to the power 1 by 2 minus 1, and then derivative will apply on the inner function 1 minus x square. So derivative of 1 will be 0 and derivative of x square will be 2x. This is minus sign as it is. This x is not under differentiation, so that will be as it is, minus derivative of x will be 1, so we have only this expression, which is 1 minus square root 1 minus x square. F prime of x is equal to minus 1 by 2 1 minus x square, 1 by 2 minus 1 minus 2x x minus, and that will be as it is. This 2 will be cancelled out, this minus and minus will become plus, and we have 1 minus x square raised to the power minus 1 by 2 after simplification, 1 by 2 minus 1, and this x and x will become x square minus, and that is again the same thing, 1 minus square root 1 minus x square whole divided by x square. So this x square, and due to this negative sign, when we shift it into the denominator, that will become 1 minus x square with positive power 1 by 2, and power 1 by 2 can be written under square root minus 1, and this minus and minus will become plus square root 1 minus x square whole divided by x square. Now we apply LCM on this numerator portion, and LCM is square root 1 minus x square, and here we have only x square minus by applying 1 into 1 minus x square, that will be square root 1 minus x square, plus this will become square root 1 minus x square into square root 1 minus x square, that will be square root 1 minus x square whole square. So square will be cancelled, we have only 1 minus x square and whole divided by x square. This is also in the denominator, so we can write it with x square, and in numerator that will be x square minus square root 1 minus x square plus 1 minus x square, and that will be x square into 1 minus x square with square root. This positive x square negative x square will be cancelled out, we have 1 minus square root 1 minus x square, and denominator will be as it is, x square into 1 minus x square. So that is actually our required derivative of the given question, which is our answer. Now the next question, question 15, differentiate this expression with respect to x. Solution: let f of x is equal to x into square root a plus x divided by square root a minus x. By applying derivative on both sides, left side will be f prime of x, and derivative will apply on x into square root a plus x into over square root a minus x. X will be as it is. Actually we are applying here our product rule, which is of the form like d by dx x and a plus x divided by a minus x. So when we apply derivative, such type of question, so we are actually using our product rule here. So x will be as it is, derivative will apply on second function, which is square root a plus x over a minus x square root, plus then square root a plus x divided by square root a minus x will be as it is, and derivative will apply on x. So this x is as it is, derivative will apply on this function, and this is of the form fx over gx. So we apply quotient theorem here, exactly the same as we use this technique in question 10 or question number 12. So this will be whole square, this square root a minus x will be as it is, and d by dx square root a plus x minus this square root a plus x will be as it is, and derivative will apply on square root a minus x, plus this portion will be as it is, and derivative will apply on x, which is 1. So first we see the second portion. This will be as it is after multiplying by 1. Now we have to just simplify this first portion in which x is as it is, and in denominator square and square root will be cancelled out. We have a minus x, and in numerator there will be simplification of the form like square root a minus x into we apply power rule here. So 1 by 2 a plus x raised to the power 1 by 2 minus 1. So that will become minus 1 by 2. And then derivative will apply on this inner portion. So when we apply derivative on a, that will become 0. And derivative will apply on x. So that is actually 1. Minus square root a plus x will be as it is. And derivative will apply on a minus x square root. The same procedure as we explained with positive sign. So the only change is negative. So that will become 1 by 2 a minus x raised to the power minus 1 by 2, and derivative of this inner portion a will be 0, derivative of a will be 0, and derivative of minus x will be minus 1. So the next step will be x as it is. This denominator will be as it is. In numerator this will be a minus x square root this 2, and this negative power will be positive by shifting it into the denominator, which can be written as square root a plus x minus this square root a plus x, and again the same almost thing, a minus x square root, and this minus 1 will be as it is. Now we have again the x will be as it is, this second portion will be as it is, this a minus x, again the same thing. Now this will be square root a minus x into 2 square root a plus x. This minus and this minus will be plus, and we have a plus x square root divided by 2 into square root a minus x. Now we apply LCM on this portion. So the LCM is 2 square root a plus x square root a minus x. We have in numerator a minus x a plus x, plus this second portion will be as it is. Now this will be again in the denominator form, so we can write it with a minus x. So we have 2 square root a plus x square root a minus x, which are in this part of the denominator. Now multiply with this denominator a minus x. Both are in actually denominator form. In numerator a minus x plus a plus x will be as it is, and again the second portion will be as it is. 2 into square root a plus x square root a minus x into a minus x, and in numerator this x, and now a minus x plus a plus x, this minus x and plus x will be cancelled out. We have a plus a 2a into x, and denominator will be as it is, second portion will be as it is. Now this 2 will be cancelled out. We have ax, and again the other portion will be as it is. Now we apply LCM on both of these two parts. LCM will be this a plus x, a minus x, this a minus x, and this square root a minus x, which we already written. So we have LCM is square root a plus x, a minus x, and a minus x. So by cancellation of this one, we have only ax, and this plus a minus x cancel out of this a minus x. We have a minus x, which is this one, and square root a plus x multiplying by square root a plus x, then a plus x square root whole square. So we have only a plus x square root will be cancelled out by square. Now the next portion is ax plus a plus x and a minus x will be a square minus x square, and denominator will be as it is. Now ax plus a square minus x square, like plus a square, and this is actually minus x square. And in denominator this square root a plus x will be as it is, and this one is a minus x, and this a minus x is the same base, so power will be combined by 1 and this 1 by 2, so that will become actually 3 by 2. Now the final answer is a square minus x square plus ax, and this one is square root a plus x and a minus x raised to the power 3 by 2. Again, this question can be solved by using, like we have discussed in our earlier questions. The question was actually f of x square root a plus x and divided by square root a minus x. We can write it as f of x is equal to x a plus x a minus x. And now we can simplify by our differentiation process. So that is actually f of x, and this one is g of x. So we can simplify it by using our product rule when we apply derivative, and that will be f prime of x d by dx square root a plus x a minus x plus square root a plus x divided by a minus x. Derivative will apply on x. So this can be solved using our earlier question. So answer will remain the same. So this is an easy exercise for you people. You must solve this question by using this technique also.